Let's start with my introduction. So this is actually week two. Week one was at Monday last week, and I'm Jyoti Sharma here, and I will be here. I will be taking this 2 hour live session. So this is my basic introduction. Uh, so this is my basic introduction that I'm a PhD student from Indian Institute of Science Education and Research. And let's come to the topic that we need to cover today. So we have to cover a reversible reaction, then concept on equilibrium, then kinetic approach to equilibrium, um, law of mass action, and activity coefficient. So firstly, my question will be like a very basic question. I will start like I have 4 or 5 questions, very basic, and then we will go on to some advanced question, very similar to the assignment question that has been given to you on NPTEL. So my first question is, we have water. So water in the liquid phase and water in the gas phase, and there is the equilibrium between these two phases, and this is the example of what. So can you give me the answer for that? Amy Lotson and Ayush Singh. I'm expecting more response from you people. Okay, Amy is giving me the answer that is temperature. Okay, Ayush, Radhika, would you like to answer this question? That we have water and we have changed the phase, like from liquid to gas, and this is the example of what? Phase equilibrium, temperature equilibrium, chemical equilibrium, and the solubility equilibrium. Okay, Ayush gave me the answer phase equilibrium. Yes, actually, phase equilibrium is the right answer. And why is this? From equation only, we can see initially it was in liquid phase, and then there is equilibrium between two phases, liquid and gas phase. So this is the phase equilibrium. And Amy gave me the answer temperature equilibrium. Temperature equilibrium will be exist when there will be higher temperature and lower temperature. And if you know the principle, then principle will say that your equilibrium will go from high temperature to the low temperature. So whenever we have the equilibrium, when we have low and high temperature, then only we will say there is a temperature equilibrium. But here, because there is the equilibrium between liquid and the gases, that's why this is the phase equilibrium. Some of the you may be confused why this is not the chemical equilibrium as well. But like in chemical equilibrium, there should be chemical transition, and if there is no chemical transition, then this the answer should be phase equilibrium. And again, this is not the solubility. There is nothing kind of solubility here in the equation, so the solubility equilibrium will not the answer. The ultimate answer will be the phase equilibrium. Now come to the next question. uh, the next question is, which of the following factor affect the speed and rate of a chemical reaction? And I have four options: concentration of the reactant, reaction temperature, presence of a catalyst, and all of the above. You people can also communicate with me, like if you are comfortable with the chat box, then it is all right. If you want to speak, if you want to discuss something with me, then you can unmute yourself and you can speak it out, because discussion is the whole solution that we have to learn. Okay, Ayush gave me answer D, that is all of above, and Amis also gave me answer option D. Yes, you people are correct. This answer is right because whenever we will we will discuss this rate of the chemical reaction, and this rate will not only depend on the concentration of the reactant, but yes, temperature, yes, the presence of the catalyst, and that's why the answer is all of the above. So okay, let me tell you first the concept of equilibrium. So let's say we have a reactant, that reactant is A and B, and this is giving us C plus D. But there is equilibrium condition that is happening between this A and B, and then C and D. So some of the reactant is changing into the product C and D, but at the same time C and D also giving these C and D will also act as the reactant and will give you the product that is A plus B. Okay, and when so first we will calculate the rate. So if we want to calculate the rate of the reactant, okay, so what will be the rate of the reactant? There may be some constant, let's say constant K1, and then it will be the product of the concentration of the reactant. Okay, so let's say I should use pen if this will allow. So if I'm saying R1, this R1 will be equal to K1, that is some constant, and then here the A and B. Okay, something happened that I couldn't write. Okay, so this is rate of reaction for the reactant, and this will be constant, and the concentration of A multiplied by the concentration of B. Likewise, if you want to calculate the rate of the product, then what will be? This will be R2 is equal to K2, and the multiply by the concentration of concentration of the product, that is C and D. Okay, and whenever we will divide it k1 by k2, because we know that in the equilibrium, the first condition of the equilibrium is that the rate of reactant and the rate of the production of the product will be same. Okay, so here r1 will be equal to r2, and if we will do like this, then kc, that is the equilibrium constant, will be k1 upon k2, and this will be nothing but the product of the concentration of c and d. Here is the multiplication sign, and the power will be the coefficient of c and d, and multiply by the concentration of a and b, and the power will be the coefficient of the respective a and b. Okay, so this kc is nothing but the equilibrium constant. And here are some points that we need to understand. The first point is that this concentration only exists at the equilibrium. Please keep in mind, because most of our question that we will have is based on the concentration will be given to you, or at the equilibrium, initially you have to calculate the concentration, then only you have to go further. Okay, so just keep in mind this concentration of a, b and c in the equation a exists only in the equilibrium. Then just see that equation a, and if you will see the product it at the numerator, and a and b is at the denominator. Okay, and if we have the kc value smaller, so kc value will be smaller only when a and b will be the larger, the concentration of a and b will be the larger. So what will happen? So what it does decipher is that the concentration of A and B is more as comparison to C and D if we have the low value of Kc. And this means that only small fraction of reactant are converted to product, because we have higher concentration of A and B when we have the Kc value smaller. Okay, but there is some case sometime Kc value is higher, but the reaction may also go from right to left, and we will discuss about this. This is the because of the Le Chatelier principle, and this is nothing but if the concentration of the product is higher, then there is a rule that it will try to compensate this disturbance, and your reaction will be reversed from right to left, so it will go from product to reactant formation. Okay, so this is the Le Chatelier principle. Okay, my next question is, what happens when the effective concentration or activity of ions is decreased below that of the actual molar concentration? And my option is the ion concentration increases, second is ion concentration remains the same, third is the effective concentration decrease due to interaction like ion pairing, and the fourth is the ion concentration becomes irrelevant. So what do you think? What will be the right answer? Sorry, so there is a two kind of concentration. The one is like normally concentration, and the second is effective concentration, or you can say the activity. So first you have to know the difference between effective concentration and regular or the normal concentration. Then only you will able to give me that answer. Can you give me answer? I'm expecting from Ayush because you are from like chemistry, so I'm expecting answer from you. And then Suhani, Emmy, Riyanka, you people can also give me the answer for this. You can give me incorrect answer as well, because I will correct you in case you are giving me the wrong answer. Ayush gave me answer B, that is ion concentration remains the same. Amy is giving me A, that ion concentration increases. Okay, so here, first let me tell you about effective concentration of ions and regular concentration of ion. So, for example, you have water, and water has been dissociate between ions, and that ions are H plus ion and OH minus ions. Okay, and if like this is not the correct example, but let's say this is only the example I have, and what will happen if the concentration of iron increases? Okay, so what will happen if the ions concentration will increase, then this, because of the iron pairing, will form some bond and will be converted into some compound. Okay, or let's say the basic compound, if we have H plus and OH minus, then this will and if the density, if you have the higher concentration of ions, then the ions will be with each other, and what will happen, it will be changed into H2O. Okay, so this is the effective concentration. Means whenever you have a higher concentration, and if the solution is not dilute, if the solution is very concentrated, then whatever the concentration of ions you had initially, these will be reduced, because you have concentration, you have higher concentration of ion, they will be like collide to each other, they will form some bonds. Okay, and because of that, the ions will be reduced. So this is, if I will say, the answer of Ayush is also correct, that ion concentration will remain the same. But if I'm talking about the effective concentration, then this effective concentration will decrease, and this will be due to the interaction like ion pairing. So I will go with the answer C only. Okay. The next is, which of the following is are ways to shift the chemical equilibrium of a reversible reaction? So, for example, you have reactant A plus B, and that was giving you C plus D. But there is the equilibrium that some of the reactant is changing into the product, and some of the product is changing into the reactant. But if you want to shift this chemical equilibrium, so how you can shift this chemical equilibrium? So you have four options: changing the concentration of reactant or product, changing the temperature of the system, changing the pressure, and all of the above. So for example, if I'm giving you example, initially I had one example that A plus B is giving you C plus D, and C plus D is also giving you A plus B. Okay, but what if you want to have this reaction only in the right side, or if you want the reaction only in the left side? So what will you do? So how you can change the shift, or you how you can shift the chemical equilibrium? Can you tell me the answer? Can you guess something? Ayush, increasing product or reactant concentration, but why not changing the temperature? But why not changing the pressure? So, if I'm telling you, like we have one reaction that is nitrogen plus hydrogen will give you ammonia. Can you tell me the name of this process? N2 plus H2 will give to ammonia, NH3. Can you give me the name of this process? Yes, Haber process. So, what will happen? Like there may be like there are two type of reaction, you people know. The one is where the temperature will increase, and the one where temperature will reduce. Okay, and can you tell me that process, the process that will rise the temperature, and the process that will like reduce the temperature? The reaction is known as what? Exothermic and endothermic, right? So if some reaction is endothermic, okay, or if some reaction is endothermic, then you can add something that will give you the reverse of that reaction. So this is how with the temperature you can also shift the chemical equilibrium. Or let's say the pressure, if you people know, mostly in the gas case, that the reaction will be go on from high pressure to low pressure. So not only just the concentration, but the temperature and pressure can also change the chemical equilibrium. Here is the explanation. Okay, the first thing is you have to understand, whenever we are changing the chemical equilibrium, then this comes under Lee Chatelier principle, and it says that the system will adjust itself in such a direction as partially to neutralize the change in condition. So, if I'm saying if we are changing the concentration, uh, for example, there are some product that will be precipitate out. Okay, so what will happen if the product is precipitating out? It means always the concentration in the product is lower, because some of the product is precipitating out. So what will happen? always from reactant the product will be formed. This reaction will not go in the reverse way, because always there is a deficiency of the concentration of the uh, concentration, okay, in the in the product side. If we are if something is evaporating, if something is precipitating out, so this is how, if we are changing the concentration, then we can shift the chemical equilibrium, and then changing the temperature. So this also can change your equilibrium towards the endothermic or the exothermic direction. And if we are changing the pressure, so increasing pressure shift the equilibrium toward the side with fewer mole of gas. As I told you, there is a like law that reaction will go on from high pressure to the low pressure, while decreasing pressure shift it toward the side with more mole of gas. Okay, so that's why the answer, all of the above will be right. Okay, the next question is, which of the following is true about amphoteric hydroxides? So options are, they are soluble only in acids, they are soluble only in bases, they are soluble in both acid and bases, they are insoluble in both acid and bases. What do you think? What should be the answer for this? Ayush gave me C answer, that they are soluble in both acids and base. Anyone else who wants to give me that answer for this question? Which of the following is true about amphoteric hydroxide? Okay, so Ayush is correct. These are the compounds, or these are the hydroxide which are soluble both in acid and base, and these are known as the amphoteric hydroxide. Okay, now the question will be uh, very similar to your assignment question, and only the concentration of some like iron, or let's say salt, will be changed, or even the compound will be changed, but the way how we can solve the question will be very much same. And so that you can solve your question, assignment question, very easily, if you are able to answer, if you are able to understand how we are solving these questions. So the first question is, I have the solubility product constant for DyOH3, and that is 1.2 into 10 raised to power minus 22. And at what pH will this compound begin to precipitate? So I don't think that you people can calculate like within second, or I don't think that I should wait much. But okay, so we should start. First we have to understand what do you mean by this solubility product constant, and then how from that only we can calculate the pH. Okay, then how we can do this? um, So let's first understand the concept of solubility. So the solubility product is a constant that represents the equilibrium between a solid ion compound and its dissolved ion. So for example, if you have one compound and that is solid in nature, if it is AB, and that is being dissociated between A plus and B minus. Okay, so if we are saying the concentration of A plus is S, that is the solubility. Okay, and because here the coefficient is also 1 for A, and coefficient for B is also 1, then what we can say is, here the solubility will be S, and the concentration of A plus will be S, and the concentration of B minus will also be S. Okay, and the solubility product is the nothing but the product of ion concentration. And as I told you, A plus is S, B minus is also S. Then the solubility product will be S multiplied by S is equal to S square. And if you want to calculate the concentration of the ion, that is S, that will be the square root of your solubility product. But this is the case when you have you have the compound, or you have the salt, where you have the coefficient is 1. Okay, so AB is giving you A plus B minus, and here the coefficient is 1 for A plus, and coefficient is 1 for the B minus. So, and this is how you can calculate KSP, that is the solubility product, and from that solubility product you can calculate the concentration of the ion. Okay, but what will be the case when there will be some different type of reaction, and this reaction will be like this. So if you have calcium fluoride, and this is giving you 1 mole of calcium ion and 2 mole of the fluoride. Okay, then your KSP will be changed, and this is how the concentration of your ion will also be changed. So how it will be? So for that solubility product, you have to multiply the product, you have to multiply the concentration of ion. But here we have 1 mole of calcium, so we have just S, but we have 2 mole of fluoride ion, then this will be the 2S, and we have to so the power should be same as the coefficient. Okay, so coefficient of calcium ion was 1, so this is S raised to power 1. But the coefficient for the fluoride ion is 2, so that's why we have to give raised to power 2 to the fluoride. Okay, so this will be solubility productivity will be solubility of calcium, that is S, multiplied by 2S raised to power 2, and this is how KSP will be 4S3. And if you want to calculate the concentration of an ion, then S is equal to this is the cubic root, right? So 4 KSP and the power of 1 by 3 again. So this is the second case, but the case can be varies, है ना? So how we can so we have third case, and in that third case what we are having, we have 3 moles of A plus ion and 1 mole of X3 X ions. Okay, X3 minus ion. So what will happen? So again, if we have 3 moles, then we have to multiply this S with the 3, and we have to do the raised to power also 3 and multiply by S, and this is how you will get the solubility product will be 27S4. And whenever you are calculating the concentration, then this will be the 27 KSP raised to power 1 by 4. So this is how you can calculate the concentration as well. Now back to my question. My question has this one. Uh, the solubility equilibrium for DyOH 3, and this will change. And if we will dissociate this into the ion, then what will get? This is Dy3 plus 3OH minus. And if you can see here, we have the 3 moles of OH ion and 1 mole of Dy. Okay, then KSP will be let's say dy solubility, or the concentration is S, and the concentration of OH will be 3S. And if we are calculating KSP, then we have to give the raised to power 3 for this 3S. Then KSP will be 27 S raised to power 4, and if we are calculating S, then this will be KSP divide by 27 raised to power 1 by 4. And this is how we have calculated the concentration of ion. Okay, so we have calculated the concentration of ion, but we know uh, we have 3 mole of OH. Okay, so how we will do? So OH concentration is 3S. So we will multiply that concentration with 3, and this is how we will get the concentration of OH minus. And if we will do the logarithm of OH, then we will have some value, and that value is 5.45. And we know that pH, the sum of pH and the POH is 14, and this is how we can calculate the pH. So pH will be 14 minus whatever the concentration of OH minus was, and the logarithmic concentration of OH minus. So this is how we will have the answer 8.55, and this is near to 8.7. That's why the answer is D for this. Okay, I think you are understanding this, how we calculated the pH, right? Okay, Ayush question is, in exam, how we will calculate the value of x raised to power 1 by 4. I don't have much idea, Ayush, but most probably you will have the access of that scientific calculator if they are giving you the question like this. Anyway, so let's come to the second question. And second question is, we have two compound. That compounds are barium carbonate and this barium, what is this, C2O4. I don't know how to tell this name, but yes, we have two compound, that is BaCO3 and BaC2O4. And if we are mixing that, okay, mixing these two salt with water, then what will be the concentration of barium ion in water? So can you just recall how we can calculate this one? Till now you just have learned that solubility product constant is equal to the product of the ions. Okay, then but here we have two salt, and in that salt, if you will see, the barium is common. So if we are mixing this, so this is very much clear from this point of view that the concentration of barium will be higher. But how much higher? How we will calculate the concentration of barium? Okay, so the thing is, how we can do this, the answer will be C. And how we can do this is, like, first you have to understand the common ion effect on the solubility. So if you have, let's say, compound AB, and it is being dissociated between A plus and B minus, and again you have one another compound, that is AC, and this is AC is being dissociated between A plus and C minus. And if you will see here, AA is common. So what will happen if you have more concentration of A plus ion? So what will happen, your equilibrium will shift to the right side, because the concentration of A is increasing. But at the same time, you have to see, at the same time the concentration of your B minus have to be reduced, because A plus concentration is increasing. And if like this is the shifting of the chemical equilibrium, and if your the product concentration is increasing, then your chemical equilibrium will be shift to the left side. Okay, and if it will be shifted to the left side, then you have some precipitating compound as well. So AB will also be formed, AC will also be formed. Okay, so AB will also be precipitate out. So you have to minus the concentration that has been precipitated out. So the thing is, we have the common ion, that is A plus. Because of that, the solubility of AB will be reduced. Why? Uh, because we have the another common ion, and then because we have the higher concentration in the product side, because of our principle, you have to shift with the reaction has to be reversed, and some of the your salt will be precipitated out. Okay, so this is thing what we got from this common ion effect on solubility. Then okay, so let's say initially concentration of A plus was S. Okay, then you also have A plus ion from AC as well. Okay, so if your new concentration of A plus ion is X, then the total concentration of A plus ion will be S plus X. Okay, this is clear. As I told you, because the solubility of AB will reduce due to the common ion A plus, so your AB will also precipitate out. And the concentration of the precipitating out AB is, let's say, Y. Then you have to minus from A plus and B minus this Y, because AB is precipitating out. Then the solubility product expression will be nothing but S plus X minus Y multiplied by S minus Y. And if the concentration of your Y is very small, then the KSP can be equal to S plus X multiplied by S. So this is the common ion effect on the solubility. Now let's come to the question again. uh, the question was this: we had two compound, BaCO3, BaC2O4, and we need to calculate the concentration of Ba2 plus. So how we can do this? First we have to we have to dissociate these two compound. And let's say we already have given this solubility product constant, that is 5.1 into 10 raised to power minus 9. But here the barium chloride barium ion will be X plus Y. Okay, and in second case also, the barium concentration will be X plus Y. And if we will divide the equation 1 and equation 2, from where we will get that X is equal to 2.83 multiplied by Y. Okay, so you have now the relation between X and Y. And then what we will do, we will go to the equation 1 again. So we have this equation 1, that is 5.1 into 10 raised to power minus 9 is equal to X plus Y multiplied by X. So we will put the value of X into it, and then this is how we can have the value of Y. And then again X, and this is how you can calculate X plus Y, and X plus Y is the exact value for the barium ion. Okay, and this will be 7.96 into 10 raised to power minus 5 molarity. Okay, my next question is, if we have one reaction and that reaction is P plus 3Q, and this is giving you 2R plus S. And here is the one condition, and condition is that initial condition of initial concentration of Q was twice that of P. At equilibrium, the concentration of P and Q are equal. Now you need to calculate the equilibrium constant K. So how you can do this? Can you remind in the mind how you can calculate this? So the thing is, you have some initial concentration before establishing the before establishing the equilibrium. Then you have some concentration of the product, and during equilibrium. And this is how, if you have some relationship between initial concentration and then the concentration at the equilibrium, you can calculate the equilibrium constant K. And how we can calculate this? So this is how we can calculate. uh, just see the table, just see the table, and in that table, uh, we in that question only, what was told that the concentration of Q is twice of the P. So let's say the P concentration is 1 molarity, then the Q concentration will be 2 molarity. And it is before establishing the equilibrium. This is the initial concentration, because uh, means your product was not formed. That's why R and S will be 0 molarity. Okay, but based on the coefficient, if I based on this coefficient, just see, R has 2 mole, S has 1 mole, Q has 3 mole, P has 1 mole. So based on that, uh, R S will be, the change will be plus X. Here for R it will be plus 2X, and this will be minus, because some product is being formed So your reactant concentration has to be decreased, and this decreased will be proportional to the coefficient or the number of moles. So P will be decreased by minus x, Q will be decreased by minus 3x, R will be increased by 2x, and S will be increased by x. And then the equilibrium concentration will be 1 minus x, 2 minus 3x, and this will be 2x, and this will be x. And there was one condition that at equilibrium the concentration of P and Q was equal, and that has been given in the question only. So what will happen, this is the concentration of the equilibrium, 1 minus x for the P and 2 minus 3x for the Q, and this is equal as given by the given from the question. And this is how you can calculate the x value. Okay, so you have calculated the x value, then what will happen? Uh, Let me clear this. Okay, so when you have calculated the x value, then you can calculate the concentration of P, concentration of Q, concentration of R and S at the equilibrium. Okay, so as soon as you have calculated the concentration of PQRS at the equilibrium, you can put into the formula, and this formula is K is equal to the product of the multiplication of the product concentration upon the multiplication of the reactant concentration, but the raised to power will be proportional to the coefficient. Okay, and this is how you can calculate K is equal to 8. So this is the equilibrium constant, how you can calculate this when you have some condition is already been provided to you. Okay, I think this is clear. If anything is not clear, you can ask me at that time only, because as soon as we will go further, it may be that I will not be able to give you the answer for this. So, should we go further for the next question? Are you people understanding what I'm trying to make you understand? Ayush, Shivamani, and Amy, are you understanding what I'm trying to make you understand? Okay, Ayush, thank you for the feedback. Okay, the next question is, if I have one equilibrium and that equilibrium is sulfur dioxide plus oxygen is giving you sulfur trioxide plus heat. Okay, and this is the gas phase equilibrium. So, what happens if the temperature is increased? So this is the case of, as I told you, the exothermic and endothermic things. So what will happen if the temperature will increase? Favors decomposition of SO3, favor formation of SO3, does not affect equilibrium or stop the reaction. What do you think? What will happen if we are increasing the temperature? What do you think? What should be the answer for this? Okay, Ayush, give me A, that is favors decomposition of SO3. Yes. Okay. So answer is yes, A. That is favor decomposition of SO3, and how this is the answer. So according to this principle, when an equilibrium system is disturbed, the system shift to counteract the disturbance. Okay, and the given reaction is exothermic because heat is being released. So increasing temperature will give you extra heat to the system, and this will act like a stress on the equilibrium. And to counteract this stress, the equilibrium shift toward the reverse, that is the endothermic reaction, meaning that more SO3 decomposes back into SO2 and O2. And this is how increasing temperature reduce the formation of SO3, but it will favor the decomposition. So I think this is clear from this solution. Okay, next question is easy. So here what we have, This is N2 plus H2 is giving you NH3, and the initial partial pressure of N2 and H2 are given, that is 8 atmosphere and the 18 atmosphere respectively. And here this constant is for the pressure, partial pressure constant is 1.8. So what is the approximate partial pressure of ammonia at equilibrium? Just keep in mind this partial pressure constant is very much same to the equilibrium constant, but here you will not use the concentration, but you will use the partial pressure of each of your product and the reactant. So how we can calculate this? So just keep in mind the initial pressure, partial pressure is given, that is 8 and 18. So so just first you have to understand what do you mean by this partial pressure at equilibrium. So for example, you had a plus b, and that was giving you c plus d, and if you are calculating this kp, that is the partial pressure equilibrium constant, so what will be, this will be the partial pressure, the product of the partial pressure of your product upon partial pressure of the reactant. But here also the power will be respective to the coefficient. Okay, so this is how you have the partial pressure for the gas A, B, C, D. This is PA, PB, PC, PD, and you can calculate as Kp is the division of this product upon the reactant. Okay, so this is the partial pressure at the equilibrium. And if we are coming to the solution, then we had reaction, that is N2 plus 3H2 will give rise to 2NH3. Uh, let's say NH3 is 1, NH3 is the 1 mole, then H2 will be 3 by 2 mole, and N2 will be 1 by 2 mole. Okay, so here we are giving the reference from this. So if this is X, then what will be happen to this? So this will be 3, this will be 3 by 2 X, right? So this is how this N2 will reduce by x by 2, this H2 will reduce by 3x by 2, and NH3 will increase by x. As I told you, initially we had something, then we have the change, and after change the equilibrium will be established, and then changed concentration will be what? Okay, and initial partial pressure is also giving 8, 18, and initially it was the 0. Then at the equilibrium we have to just minus, as I told you, like in that table also, first we calculated the initial, then after initial the change, and then the concentration at the equilibrium. What we have to do is we have to subtract from initial to the change. Okay, and we already had calculated the change, that is x by 2 minus 3x by 2 and the 0. So we will subtract it from the initial partial pressure, and then of as soon as we have the value for the partial pressure at the equilibrium, we can put it into the formula, that is the kp is equal to the product partial pressure upon the product of the partial pressure of the concentration, and this is how we can calculate the x. Okay, and the partial pressure of NH3 at the equilibrium will be 2 minus 2.86, and the answer will be 2.86. Okay, so this is how we can solve the question of the partial pressure. Okay, this is very much say easy question actually. So initially you had one reaction, that reaction is x plus 3y is giving to 2x, and here the equilibrium constant is 81. But the reaction, now the reaction is x is giving you 1 by 2x plus 3 by 2y, and you need to calculate the equilibrium constant for this reaction. So how you can do this? Can you see this is a kind of reverse reaction, right? So initially it was x plus y was giving you z, and then z is giving you x plus y. So whatever the equilibrium constant you had for the for the reaction that was going in the right side, so for the calculation of the equilibrium constant that is going to the reverse side, then what will you do? You will just do the reciprocal of your chemical equilibrium constant. Okay, but you have to see the coefficient, and based on that coefficient you have to give the power to that value according to the coefficient. Okay, so how we can do is, so okay, initially we have the reaction x plus 3y was giving you 2z, and here the k was 81. Okay, and you need to determine the equilibrium constant for the another. But if you will see, this, if we will reverse the reaction, so the reversing reaction will be 2z will give rise to x plus 3y. Okay, and here we can calculate the new equilibrium constant of this reaction, of this reaction is the reciprocal of 1 by k, and that is 1 by 81. Okay, but here if you will see this and this, so how you can get the reaction from first to second is that just what we are doing, we are reverse we are just dividing this by 2, then only we are having this reaction. So if we are dividing by 2, so we have to take the square root of 2, and then if we are doing the square root of 2, then the new constant equilibrium value will be 1 by 9. Okay, and this will be your right answer. So this is how we can calculate the equilibrium constant of any reaction that has been reversed. Okay. Okay, now let's come to the next question. Okay, the next question is, if we have the reversible reaction, and this reversible reaction is we have the ammonium ion, and that ammonium ion is giving rise to ammonia plus H plus ion. At equilibrium, if we are adding the ammonia, that is NH3, what would happen? Increase ammonium concentration, the first option is that. The second question is, this will increase H plus ion concentration. C is increase the equilibrium constant, and D is decrease the equilibrium constant. So what do you think, what will be the answer for this? This question is again based on the principle, Lee Chatelier principle. If we are adding ammonia, so what will happen? Ayush gave me A answer, that will increase ammonium concentration. Okay, so yes, this will be the answer, that it will increase the ammonium concentration. And again we let me again explain you the Lee Chatelier principle, and this is that when an equilibrium system is disturbed, then the system will shift in the direction that counteract the disturbances. So whenever we will add ammonia to the system, then your equilibrium will shift to the left to consume some of the added ammonia. So whenever you have more ammonia, so what will happen, then this has to be consumed. Okay, and if this has to be consumed, then the reaction will be reversed. Okay, reaction will be go to the left hand side, and so that's why more ammonium ion will be formed, while H plus concentration will decrease. Because if the ammonium ion is increasing, then obviously, and ammonia is coming extra from outside, then obviously H plus ion has to be decreased. So this is how the first option was correct. Okay, this is the another explanation how we can explain it. This is we have to the equilibrium has to be shifted to use up ammonia, and this is how the NH4 concentration will increase, H plus concentration will decrease, because the reverse reaction consume H plus ion. And this is how the equilibrium constant doesn't change, because it only depend on temperature, but the NH4 concentration will increase. Okay, now let's come to the next question. This is again simple question. So what you have is, you have X, and that X has the mole 1.5, and it is being mixed with the Y, and the mole of Y is 3, and the mixture is placed in a 1 liter flask until equilibrium is reached for the reaction. Okay, so initially X and Y was separated. Okay, and the X has 1.5 mole, Y has 3 moles, and then they are mixed in a 1 liter flask, and then uh, they are mixed till the equilibrium is reached. Okay, at equilibrium, okay, initially Z and W was 0, because we didn't mix. But after mixing, after establishing the equilibrium, we have some moles of Z, and this is zero point 0.4 mole of Z. And now you need to calculate the equilibrium constant for the reaction. So for calculating the equilibrium constant for the reaction, you should know the concentration of X, Y, Z, and W at the equilibrium. Okay, and these are the mole, these are the mole of the initial concentration, not of the equilibrium concentration. Okay, so the first step will be to calculate the concentration of X, Y, Z, and W at the equilibrium condition. Okay, then only you can calculate this equilibrium constant. So how we can do this? So again, we have the table, and that table have the species, that is X, Y, Z, and W. Initial mole were 1.5, 3, and here 0, 0. Change in mole, so here we have 2Z, and here we have 1W. So 1W means 1 mole of W was formed, and here 2 mole of Z was formed. So that's why here it will be plus X, and here will be plus 2X. And X and Y concentration have to be reduced, because Z and W is being formed. So it will be minus 2X based on the number of moles of Y, and minus X based on the number of mole of X. And the equilibrium mole will be, you have to divide from initial mole to the change in mole. So 1.5 minus X for X. For the Y, this will be 3 minus 2X. For the Z, it will be 2X. And for the W, it will be the X. But in the question that is given, that zero point 0.4 mole of Z is formed. So this is the concentration at equilibrium for Z. So this one will be equal to 0.4. Okay. So, and this is how we can calculate the X. So X will be 0.2, and based on that we can calculate the equilibrium concentration. So for the X, concentration will be 1.2, for the Y this will be 2.6, for Z it will be 0.4, for W it will be 0.2. And now you have the equilibrium condition. Now you have the formula for the equilibrium constant, and you will put all the value into that, and you will get this. So let me clear this. Okay, so your equilibrium constant expression is like this. This is your reactant, this is your, sorry, this is your product, this is your reactant, and the raised to power is proportional to your coefficient or the number of moles. And then you already have calculated the concentration of X, Y, Z, and W. You will put every value, and then this is how you can calculate the value of K. And this is 3.64 into 10 raised to power minus 3. I think this is clear how we can calculate if we have something of the equilibrium something about the equilibrium concentration is given. then obviously we can calculate the equilibrium constant value. Okay. The next question is, this is again not much difficult. Again, very simple. Again, what we already have done. So we have the weight of N2, weight of H2. So weight of N2 is 40 gram, weight of H2 is 10 gram, are kept at 450 degrees Celsius in a 2-liter vessel. The equilibrium mixture contain 34 gram of ammonia. What is the approximate value of equilibrium constant for the reaction? So how you can calculate this? So see here, the solution volume is 2 liter. Okay, and then we have given this mass of N2 and H2. So I think from here you can calculate the initial concentration. So initial concentration is in molarity, right? And you know that molarity is equal to given mass upon molar mass upon the volume of the solution. And you know the molar mass of N2 and H2, right? So based on your value given, like 40 and 10, based on that you can calculate the initial concentration of N2 and H2. Okay, and then based on your stoichiometry, what you can do is you can calculate also the change. Okay, and if you have calculated the change, then you can calculate the equilibrium concentration based on that change, because you have to subtract it, right? And then this is how you can calculate the equilibrium constant. So how we can do this? So the number of moles we are calculating for N2, this will be 40 upon 28. This is 1.43. And the number of moles for H2 will be 10 plus 2 given mass upon molar mass. And then the moles of NH3 at the equilibrium, that is 2. Okay, so we have calculated this, we have calculated this, and we know that before establishing the equilibrium, before establishing the reaction, the concentration of ammonia was 0. Then based on the stoichiometry, based on this 2, so the change in the mole will be, so this number of moles will be increased. This is 3 and here it is 1, so this much moles will be decreased, this much mole will be decreased for the N2. And if we are calculating the equilibrium mole, then this will be 1.43 minus x, 5 by 5 minus 3x, and this is 2x. And then we have 2x is equal to 2, because as I told you, if something is given about the equilibrium concentration, then we can calculate. So it has been given that the number of moles for NH3 at equilibrium was 2. Okay, and this is how we calculated the value of x, and based on that value x, we can calculate the concentration of N2, H2, NH3 at the equilibrium. Okay, and then we just need to write the equilibrium constant expression. We have to put all the values, and this is how we can have the equilibrium constant value, that will be 40. So this is how we can solve this question. Now coming to the next question. So we have freshly precipitated lead sulfate, and this is I think silver bromium R. So we have four options, that is both are yellow crystalline, and the second is PbSO4 is white crystalline, and AgBr is pale yellow curdy, and C is PbSO4 is pale yellow curdy, and AgBr is white crystalline, and fourth option is both are curdy white. So can you tell me the answer? Okay, Ayush, you are the lone one who is active here, so I can tell you the answer. Okay, Ayush give me B answer, that is PbSO4 is white crystalline and AgBr is pale yellow. Yes, so you are right. And I think this is just based on based on the laboratory work only. So how this precipitate will give you the color. So if I'm talking about PbSO3, then this is white crystalline, and It formed due to the formation of Pb ions with the S4 ion, and here it will be precipitate out. Then we have the silver bromide, then this is pale yellow antimony, and this Ag plus Br will give you the precipitate out AgBr, and this is how you have that nature of your precipitate. Okay, again, very much similar question and very basic. And this is a 1 liter reaction vessel contains 2 mole of SO2, 4 mole of O2, and 5 mole of SO3. So these are the moles that are at the initial stage. What is the approximate equilibrium concentration of O2 if the equilibrium constant is equal to 10.5? So how you can calculate this? So again, the methodology will be same. Initially you have the initial moles, then changed moles, and then the moles in the equilibrium, and then we already have the value for equilibrium constant, that is 10.5, and this is how you can calculate. So let's see how we can do this. So initial mole for SO2 is 2 moles, O2 it is 4 moles, and SO3 it is 5 moles. And based on that reaction, based on the number of moles, it is 2, it is 1, and it is 2, then this has to be reduced by 2x, this has to be reduced by x, and this has to be increased by 2x. So minus x plus 2x minus 2x, and the equilibrium concentration will be 2 minus 2x from here, and from here you can calculate this one, and from here you can calculate this one. So this is 4 minus x, and this is 5 plus 2x, and this is how we calculated the concentration at the equilibrium. But this is in the form of x, so this x we can calculate because the equilibrium concentration is given already. So how we can do this? um, Let me clear this. Okay, so K is equal to SO3 raised to power 2 upon SO2 raised to power 2 multiplied by O2. We already have calculated this value, and then we will put every value, and then we will have the X value, that is 1.9, and the concentration of O2 is at the equilibrium is 4 minus X, and that's how we will have the value 2.1 molarity. So this is how we can uh, calculate the concentration at the equilibrium of any species if equilibrium constant is given. Okay, now coming to the next question. Okay, here we have lead sulfate, and this is white solid that dissolve in water to an extent of 0.0031 gram per liter. Okay, at 25 degrees Celsius, estimate its approximate solubility product, that is KSP, and the molecular weight of lead sulfate is given. This is 303.26 gram per mole. So how you can calculate this? So just keep in mind, this is gram per liter. Okay, so this is gram per liter, and this is gram per mole, and you know that the uh, molarity is mole per liter, right? So because of that, the molecular weight is given, so that you can change this gram per liter to molarity. Okay, so you have to divide this with this, so that you have the molarity, that is the concentration. So if you have that concentration, then based on the equations, based on the coefficient, we can calculate. Let's see how we can calculate this. So the condition is that this lead sulfate will be will be dissolved into the water, and will dissociate between lead ion plus sulfate ion. Okay, and then because here it is 1, here it is 1, and here it is 1. So 1 mole of PbSO4 will dissociate into 1 mole of lead ion and 1 mole of SO4 ion. Okay, and the here the solubility is S, and this is also S. Then Ksp will be S into S. This will be the S square. Then, so if we are calculating the solubility, so if we are calculating the S, this is mass by molar mass. Then this is how mass is given already, molar mass is given. Then this is how we can calculate the solubility. And if we have calculated the solubility, then the square of the solubility will give you the Ksp, and this is how we can calculate the solubility product constant. So this will be 1.6 into 10 raised to power minus 8. Okay, coming to the next question. These all questions are very much similar to the question that has been given in the assignment. Just I changed the compound name and the concentration, but the language is very much similar. And this is how, like, this is from here you can learn how you can solve each and every assignment question. Anyway, the next question is, consider a solution that has been saturated with calcium sulfate, and here the concentration of ions of calcium and sulfate is given, that is 1 into 10 raised to power minus 6 molarity, and the solubility product is also given, that is 2.4 into 10 raised to power minus 5. If the concentration of calcium is increased by adding calcium chloride with the concentration of 5 into 10 raised to power minus 6 molarity, what will be the final concentration of the sulfate ions in the solution? So this is again the case of common ion effect. So if we are increasing the concentration of calcium ion into our solution, then sulfate ion has to be reduced. Initially the sulfate ion is 1 into 10 raised to power minus 6 molarity, but this will be changed with the time, because we are increasing the concentration of the calcium. Then how we can calculate again? And this is the question based on the solubility product. Then we have to first have to know the S value. S value is given for the initial, but after adding the calcium ion, then what will be the value of this S? Based on that S value, we can calculate the final concentration of sulfate ion. So how we can calculate this? Let's see. So what we will do, so initial concentration is already given. This is given in the question. This is also given in the question, that solubility product of this calcium sulfate is 2.4, and the additional Ca is added at the concentration. This is also given. Okay, initially it was 1.1 into 10 raised to power minus 6. The sulfate concentration was 1 into 10 raised to power minus 6. This is already given. But when we are adding the calcium chloride, then this has to be increased. And how much it will be increased? This much. Right. So what we will do? We had this one. So we have to add this 5 into 10 raised to power minus 6 molarity into this concentration, 1 into, but we have to do the minus, because the sulfate ion will be reduced, so this has to be minus, this we have to be plus. Okay, so the new calcium ion will be, you do have to do plus, and this is how we can calculate. But for the, let's say, why be the amount of sulfate that precipitate from the solution? Now you have to see, whenever we are increasing the calcium ion concentration, then your reaction will be reverse in nature. So some of the calcium sulfate will be precipitate out. So you just have to be calculate how much sulfate is being consumed while precipitating out the calcium sulfate. Okay, so this is your calcium, new calcium, but you have to subtract it. You have to subtract y. and this y is nothing but the amount of SO4 that precipitate from the solution. And you also have to minus that you have calculated that you initially had 1 into 10 raised to power minus 6. And then let me clear this. Okay, so this is how you have the equilibrium constant, and then this is your new calcium ion concentration, and this is your new sulfate ion concentration. See, because calcium sulfate is being precipitated out, so how much concentration is precipitated out? You have to do minus. Okay, and this is how you can calculate the value of y, and this is how this sulfate ion will be 2.4 into 10 raised to power minus 6, and this will be your right answer for the final concentration of the sulfate ion. Okay. You just need to calculate the solubility product of magnesium hydroxide if the solubility is 0.075 gram per liter. Okay, so you know that first you have the magnesium hydroxide. You will dissociate this magnesium hydroxide. So what you will get? You will get the magnesium ion, and you will also get the hydroxide ions. Okay, then based on the number of moles of this ion that has been released, your formula of KSP will be defined. Okay, then as soon as the KSP formula will be defined, you have the solubility, that is S is equal to 0.075. But see, this is in gram per liter, but you need this value in mole per liter because we need the concentration. So what you have to do is you have to you have to divide it by the molecular mass of magnesium hydroxide. So as soon as you will get your concentration and you have the formula of KSP, then you will get the value of KSP. So how we can do this? Let's see. Let me clear. Okay, so very the basic thing is that first you need to have the reaction. So the reaction will be, you have the magnesium hydroxide, this will be changed into magnesium ion and 2 moles of hydroxide ions. Okay, so if the solubility is defined as S, then the number of the concentration of Mg2 plus is S, and because here it is 2 mole, then this will be 2S. And as I told you, when we are calculating this KSP, this 2 we also have to be give at the power also. So this will be S multiplied by 2S raised to power 2, and this will be 4S3. But as I told you, the concentration is giving in gram per liter, but we need mole per liter, so we have to change. We have to uh, we have the molar mass. Then this is how, if we are dividing this by molar mass, then we are having the concentration in molarity. Okay, and this is how this S has been calculated, and this is what we needed. So this will be S is equal to 1.287 into 10 raised to power minus 3. So this is how you can uh, calculate the concentration of OH and Mg. For OH, you have to multiply with 2. So see here, this KSP is equal to 4S3. This is 4S3. Then you calculated the KSP, and you, if you have calculated the KSP, then uh, this is this is how you can calculate. Actually this is not very much same to this, but because the options are like this only, so the approximate value we have to match from the given options only, and this is how we can calculate the solubility product of magnesium hydroxide. I think this is clear. Now let me come to the next question. We have 20 question total, because 20 question is in assignment, and all the question have the replica, and that replica I'm giving you in this presentation so that you can solve your assignment. So 20 question in the assignment, 20 question I also have that the replica of the assignment question, kind of. Okay, so again, this is again very much same question. The solubility product is given. Okay, and you need to calculate the solubility, but it is in gram per liter. So initially you have the solubility in mole per liter, but you have to change it into gram per liter. And again, you must have, first you must have the equation, and based on that equation, based on number of moles we are having, we can have the equation, we can have the formula for ksp. And if we have the formula for ksp, we can calculate the S, that is the solubility. And then we have to change this solubility from mole per liter to gram per liter. Okay, so how we can do this? Let's see. Okay, so we have the equation, and that equation is pbi2 is being dissociated into two ion, that is pb2 plus and uh, 2i minus. Okay, so here we have 2 mole, here we have 1 mole, and here we also have 1 mole. So let's say the solubility is S, so the concentration of pb is S, but here we have 2 mole, then this will be 2s. Okay, and we know that ksp is s, and here because there is a 2 mole, then 2s, and then square of it. Okay, so this will be 4s3. Okay, and we already have given the value of ksp, that is 8 into 10 raised to power minus 6, and this is how you can calculate the value of s. Okay, so as soon as we are uh, calculating the value of s, as we are calculating the value of s, then because this is s3, then for the s we have to do the cubic root, then we have calculated this value s, then we have to change it into gram liter, so we have to multiply with the molar mass, and if we have multiplied, then we can calculate this solubility in gram per liter. So this is how we can solve this question. Now coming to the next question. The next question is, solubility is given. So solubility for some compound, that is M3Y, is given, and that is 2.5 into 10 raised to power minus 18, and you need to calculate the solubility. So again, you first have the equation, and that equation will be M3Y will give rise to the ions, and that ion will be uh, M3 plus and 3Y. Okay, and this is how you will have the number of moles, and then if you have number of moles, I show you. So this is the equation. So this is M3Y, this will give you the 3 mole of M and 1 mole of Y. Sorry, I spoke wrong. So here we have the 3 mole of M and the 1 mole of Y. And so if the solubility is X, if the solubility is X, then the concentration of M will be 3X, and the concentration of Y will be X. Put this into this equilibrium solubility product, then this is 3x and the cube of this 3x, because whatever the number of moles we have to give the power to that. So this is 3, and for y this is x, and this is how ksp is equal to 27x power to the 4. And in the question only, the value of ksp was 2.5 into 10 raised to power minus 18. If we are putting this value, then we can easily calculate x4, and this x4 will be 2.5 into 10 raised to power minus 18 upon 27, and then we have to do we have to take the fourth root of both sides so that we can have the value of x. And if we do have the value of x, then we can easily calculate the value that we need to calculate, and this is 4.6 into 10 raised to power minus 6 molarity. This is how we can again solve the question. Now coming to the next question, let me solve this. Okay, this is again very much similar to the question number 16. Again, the solubility product is given for PbI2, and this is 1.4 into 10 raised to power minus 8, and you need to calculate the solubility again in gram per liter. Okay, and the molecular weight is given very much similar to the question number 16. Everything we have to do is very much same, but just you need to see the number of moles of ions that are being dissociated into from the compound that is PbI2. Okay, so let's see the reaction. So this is the reaction. PbI2 is being dissociated into two ion, Pb2 plus and 2I minus. Okay, so here we have two ions of iodine, and here we have sorry, 2 moles of iodine, and here we have the 1 mole of iodine. So let's say we have the solubility of this compound is S, then the concentration of Pb will be S because we have just 1 mole of it, and the concentration of I will be 2s because it this compound will dissociate to give two ions. Again we have to put it into the formula, then Ksp is equal to the concentration of Pb multiplied by the concentration of iodine, and here it will be the raised to power 2 because we have the number of moles that are 2. Then this will be s multiplied by 2s and the raised to power of 2. Then this will be 4s3, and this is how from this we can calculate the value of s. So let's see what happened. Something went wrong. Are you able to see my slides? Are you able to see my slide? Okay, okay, now you can see, I think. Okay, okay, thank you, Ayush. So here s cube will be like this. Let me. mm, Okay, so here s you can calculate s. Let me take the pen. Yes, so I think there is some problem with this, but anyway. And then we have to convert this mole per liter to gram per liter, and how we can do this, because we know that this is molarity, mole per liter, but if we are needed to change into gram per liter, then we have to multiply this molar mass. So we already have the molar mass. If we will multiply this with molar mass, then our value will be in gram per liter. Let me see. Okay, so next come to the. Okay, so we have 18th question. So this is last third question we have. The question is colloidal FeO3, FeOH3 in an aqueous medium may be positively or negative charged due to adsorption of ion. The ion that is most likely to be adsorbed is ferrous, OH minus, ammonium, or chloride. So what do you think? What is the right answer? Ayush, can you give me the answer for this? So we have colloidal FeOH3 in an aqueous solution that may be positively or negative charged due to adsorption of ions. And then you have to tell me the ion that is most likely to be adsorbed is what? Fe3OH minus and A plus and Cl minus. Okay, so this is based on your colloidal behavior. So, colloidal particle can be either take a positive or negative charge, and this is based or depending on the ion that is adsorbed on its surface. Okay, and this is the one example of this FeOH3, OH3 is an example of colloidal particle. So, if you will see this FeOH 3 when dispersed in an aqueous solution is typically composed of Fe3 plus ions, and it will be surrounding by hydroxide ion, and these hydroxic ions are more likely to form a stable colloidal solution by interacting with Fe3 ions present in the colloid. And here this colloidal will be typically negatively charged because it tend to adsorb Fe3 ions from the solution, and this is giving you the answer that this Fe3 plus are likely to be adsorbed on the on the surface of the colloidal FeOH3, and this will give you the ultimate charge. Now coming to the next, this is second last question you have. Something is happening. I'm not able to see my screen, but anyway. Okay, the solubility of BaSO4 in water is again giving. So this is solubility, and you need to uh, confused between OH minus and Cl minus. In last question, Ayush, which question? So this is OH minus. Okay, okay, Ayush. Thank you. Okay, now here again the solubility is given, and if the solubility is given, you can calculate the solubility product. And how you can calculate the solubility product? The thing is, again you have to have the equation or the reaction equation. So this BaSO4 will be dissociated into ions. So you have to see how many number of moles of that ions will be produced. Based on that number of moles of that ion, you have the value for ksp. If you have the value of ksp, then so there will be the equation of ksp, and if the solubility s value is given, then you can automatically can calculate this ksp. So how we can do this? Let's see. This BaSO4 we can I don't know why this is not giving me the ink. Let me see. Okay. Anyway, so BaSO4 is being dissociated between two ions. That ions are Ba2 plus and SO4 2 minus. And here we can see the number of moles is 1 for Ba and also for SO4. Okay, so this is very simple. Then here Ksp will be S into S, and this will be the S square. There is nothing to worry because the mole is same for Ba2 plus and SO4 2 minus. So this is S into S, and this will give you the S2. And here, if you have the KSP, the value of KSP is given, if sorry, if the what has been given, let me see, the solubility is given, S is given. Okay, if S is given, then you can calculate the KSP. Okay, so S value was 2.2 into 10 raised to power minus 4, and if we are giving rise it to 2, then this will give you 4.84 into 10 raised to power minus 8. And this is this value was not among the MCQs, so that's why whatever the nearest value we had, so we have to rely on that value only. So don't worry about this the last line, but just keep into mind how we can calculate this solubility product. So next, coming to my last question. So this is last question, very much uh, easy. That Lee Chatelier principle is applicable to what? Irreversible reaction, reaction at a high temperature only, then system in equilibrium, and then reaction with no change in concentration. I think this you people, all people can give you, you all people can give me this answer. Ayush, give me C. We talked about this principle a lot, like what do you mean by this principle, what will happen, how we can change the chemical equilibrium with increasing the temperature, decreasing the, let's say, pressure, or increasing or decreasing the concentration. We talked about a lot about this Lee Chatelier principle. So yes, Ayush, this answer is right. This principle is only valid when your system is in equilibrium, right? So I have some explanation for this. So this principle state that if a system at the equilibrium is subjected to change in concentration, pressure, or temperature, the system will shift in such a way as to counteract the imposed change and will restore the equilibrium. Okay, so this principle can only be applied to the system that are already at equilibrium, because it describe how a system responds to disturbance while maintaining a system to dynamic balance. So these were all questions that I had. I think all questions, the solution, the explanation is clear to you. If you people have any doubt, if you people have any query, suggestions, then you are welcome to provide. Either you can communicate, either you, or you can write in the chat box what, like how I can improve this session, or like any query. If you have any doubt related to the question that has been solved, any query to related to the assignment question and all, you can ask. Otherwise you people can leave, because I have completed this session. I will wait for 2 or 3 minutes, and then I will leave this meeting for all. Thank you, Ayush. Thank you so much. And this session will be again on Monday only, from 6 to 8, and you people are welcome to join it again. The slides and the video recording link is already given, I think, on NPTEL, so you people can also visit, and you can watch that video or the content that I already have explained right now in the live session. So you can see that content, and you can be ready for your if you are applying for the certificate. If you have applied for the certificate, then you can go for the content that the link of that content has been given. Okay, thank you so much, guys. I'm leaving. You people can also leave. Thank you, Ankita.
Radhika,